Thank you for sending this question. This question came in from a student about homework problem from section 5.4. It's a problem that has an even function and it's an absolute value, and we're asked to evaluate the integral. Now it's important to notice some keys about how we knew that this was going to use symmetry. Now, of course, there's a key here in the directions, but the other key, if we weren't hinted towards looking for symmetry, what we'd want to notice is that we've got the opposite of A to A. When we have two indices that are opposites, there's a good chance that symmetry might be beneficial. Now, we could do this example without symmetry, but doing it with symmetry is in fact going to simplify it. Now, let me make sure let me erase that. Let me make sure we follow all the proper steps. And the first step is to check whether this is even or odd. So to check whether it's even or odd, I'll evaluate f of the opposite of x, which would be 5 minus the absolute value of the opposite of x cubed. But when I do that absolute value, I get that it changes that opposite of x to always being a non-negative x. So it's just x cubed, right? So whether it's negative inside or not, the absolute value changes it to a non-negative. So what I can see here is that f of the opposite of x is equal to f of x, which means that this function is even. Because this is even, I could use this symmetry. Because this is even, I could simplify this process by integrating not from -2, but from 0 up to 2. I'm not changing anything else inside except, well, let me come back and do it one step at a time. I'm not going to change anything else inside the integral except those indices. Now the next thing I can notice here is that this absolute value of x, because our interval is going from 0 to 2, the absolute value of x is always non-negative, right? Anything I picked in between there. The absolute value is always just going to come out to be x, right? 0, 0, 2, 2. The absolute value of x is going to be equivalent to x from this interval, on this interval. So for that reason, I could rewrite this a little bit more and say drop that absolute value. And now I'm all set to go. Now I'm ready to integrate. Here's the easy part, right? 2 times the quantity of, if I integrate from 0 to 2, when I integrate 5, it's a constant, I get 5x to the 1 over 1, or just 5x, minus x to the 1 more than 3 is 4 over 4. And now all I'll need to do, and don't lose this 2, by the way, don't lose the 2, don't drop that 2. Now the second set, I'm just following this through to make sure everyone sees every step. Really, I don't have to include this minus second set because this is going to turn out to be a 0. But let me show you why instead of just ignoring it. So we'd have 5 times 2 minus 2 to the 4th over 4 minus 5 times 0 minus 0 to the 4th over 4. Let me substitute those numbers in. So 5, when I let x equal 2, 5 times 2 minus 2 to the 4th over 4. And then when I let x equals 0, it's these indices here, right? 2 to 0, and then subtract them. This is going to come to a 0. So we have 0 minus 0, so 0. But when I simplify this first segment, I'd have 10 minus 2 to the 4th divided by 4, so 16 divided by 4 is 4, or in other words 6, so 2 times 6, which is 12. And that's the final answer. Now let me go back over the tricky part of this problem. The tricky part of this problem really is this absolute value, right, and the symmetry. So to start with, for the symmetry, because it's even, instead of going from negative 2 to 2, I could double the integration from 0 to 2. That's because of the symmetry. And then, with the absolute value, because this absolute value of x from 0 to 2 is always, the absolute value of x is always equivalent to x from when x is going from 0 to 2. In other words, when x is non-negative, the absolute value of x is equal to x. So for this segment, for this interval from x equals 0 to x equals 2, I would just have x cubed. I can drop that absolute value. I hope that this has helped explain any part of this that seemed a little tricky. Please let me know if you need further explanation on any part of this really good example.